Okay, now we're going to talk about this complex conjugate. It's very easy to find the complex conjugate because really all you have to do is change a plus and a minus. So look at this one, 2i minus 15. So the complex conjugate would be 2i plus 15. That's the answer there. But let me show you why that is the complex conjugate. If I were to multiply these together, right, this is a difference of squares. Or even if you didn't remember that and you FOILed it, it'd be 4i squared plus 30i minus 30i minus 225. So the plus 30i minus 30i, those cancel each other out. So you're left with 4i squared. Now I squared is negative 1 times 4 is negative 4 minus 225 is negative 229. The whole reason we use the complex conjugate is to get rid of the imaginary numbers, the complex numbers, which we're going to need when we do fractions on the next example. So again, you just have to change positive, negative stuff. B, we have negative 4i, so the complex conjugate would be positive 4i. 9 minus i, we just have to change that minus. We just make it plus. 9 plus I. And the last one, I plus the square root of 3. We make it I minus the square root of 3. And that's it. So we'll start the next problem because these ones are very complicated. So dividing complex numbers. So remember with radicals, you couldn't have a radical, the square root sign, in the denominator. So we figured out something we can multiply to get those radicals to cancel out. Same thing here. You can't have imaginary numbers in the denominator. So we are going to multiply them out using that complex conjugate that we just did. So if you look at the denominator, and again, all we have to worry about is the denominator. It's fine if imaginary numbers are on top. We're going to use the complex conjugate. It says 1 minus 2i, so we're going to multiply by 1 plus 2i. But if you do that in the denominator, you have to do that in the numerator as well. 1 plus 2i. So we're going to have to FOIL up on top. 5 times 1 is 5. 5 times 2i is 10i. It sounds like someone from Australia is talking about an antenna. 10i. 3i times 1 is 3i. And last 3i times 2i is 6i squared. Now, handling the denominator, it's difference of squares. So square the first term. 1 times 1 is 1. Put a minus and square the last term. 2i times 2i is 4i squared. Let's finish the bottom here. I squared, remember, is negative 1. So the denominator is now 1. Negative 4 times negative 1 is positive 4. So it would be 1 plus 4, which is 5. We still have to mess with the top, though. So up top, let's see. 6i squared. I squared is negative 1. So we have 5 plus 13i, right? 10i plus 3i. And then plus 6 times negative 1. So that makes it minus 6. So if we combine our like terms, 5 minus 6 is negative 1 plus 13i. That would be our final answer there. Now, I want to show you something, because you might end up with something like 2 plus 7i over 4. And I want you to think of that as two separate fractions. It's like 2 fourths plus 7i fourths. And you can simplify 2 fourths to 1 half plus 7i over 4. This would be simplified all the way. But if we look, if we had two separate fractions, negative 1/5, you can't simplify. 13 fifths, you can't simplify. So that's why it's fine just leaving that one as one